Right, welcome, ladies and gentlemen, to this London consultation meeting on the future of the CMI Mortality Objections model. Some brief introductions. My name is Tim Gordon. I chair the Mortality Objections Committee of the CMI, whose primary responsibility is the CMI model. I'm joined today by some of my fellow committee members, left to right, hopefully John Palin, who's the committee secretary, but is also key to technical modelling carried out by the CMI Secretariat, Brian Sewell, Matt Fletcher, and Steve Bale. And we have a couple of other members of the CMI committee in the audience, Neil Robjohns and Piero Cucciavar, if I've got that right, Piero. So this session, I should warn you, is being recorded. A copy of the recording will be available on the CMI website. All views, so it's a consultation meeting, so all views that are expressed tonight are personal views. They're not necessarily the views of our employers or indeed the CMI or the IFOA. Ooh, there we go. Right, so CMI Mortality Objections model has undoubtedly been successful. It is close to universal in its UK adoption for disclosure and benchmarking. It is also widely used for actual analysis of mortality improvement. So a lot of individual insurers or reinsurers, when they, for instance, they go and look at an overseas locale, first thing they do is calibrate the CMI model to go and see what answers that gives. It's also a starting point for other people's models. So I'm not sure how many people are aware that the model in the US, MP 2014, and the just released 2015 version is actually very, very closely based on the CMI model. And the NAPF longevity model, if you're familiar with that, then the starting point for that, again, was the CMI model. So it has been very successful. But expectations of mortality modeling are increasing. So in the environment I work in, I cannot help but notice that net discount rates are even lower in the UK. And there is greater sophistication in longevity deals, and I might highlight slicing and dicing, which has a habit of homing in on any weaknesses in your longevity basis. And if nothing else, I notice that the population of expert actuaries in this field has expanded enormously from when the CMI model was first created. We do have some concerns with the current model. First of all, it's not actually a statistically based model. I mean, essentially all we're doing is we are smoothing surface of past mortality improvements, and then onto that we stitch a projection of future improvements. But there's nothing intrinsic about that process that says if we've got a good fit to the past, we have somehow a good way of projecting the future. And that's not necessarily a bad thing. I mean, it's a pragmatic choice, but it does lead to some other issues when we try and analyze the model. So first of all, it's the fact that simply when we fit the model to the past, it's not evidence that the model is a good predictor of the future. We actually have to do extra work to go and test that. But in particular, it makes it very difficult to answer the question, and I put it there in this is the way I think about it. It looks like technical, but basically, if I have 1 year of extra data, how much should the present value of a portfolio of annuities or a pension plan's liabilities change? What's a reasonable answer for that? And at the moment, we struggle to answer that question because we don't have a statistical framework in which to base it. So it's not to say that by any stretch of the imagination that statistical models are the answer to everything, or even that we can get some sort of complete statistical model that will help us address it. But at the moment, we struggle even to get going. It is also cumbersome to calibrate. This may not matter to you if all you do is you use a CMI model because it's loaded onto your valuation system. You run your valuation, you just pick off CMI 2014 long-term rate 1.5 core model because it's all there and you don't do any extra work to get to that. But if you're trying to use this in a stochastic framework or something like that, the notion of doing 10,000 sims of the CMI model is, you just can't do it. It's not a sensible thing to go away and simulate stochastically. It also has lots of parameters. So first point I'd pick out, it's very difficult to know which parameters affect the DPV by D new information. So if we had a simple model, so if we were talking about a Lee-Carter model or a Cairns-Bechdad model, you can look at the parameters in that model and have some intuition about how responsive they're going to be just by reading off the values of the parameters. It's very difficult to actually identify how responsive the CMI model is. It's very difficult to predict that in advance. So we're aiming for an improved model, but at this point I should give some reassurance that we're not setting out on this review just for the sake of it. If we end up and we take a view that maybe tweaking the existing framework is the right answer, then that's what we'll do. So we don't have some need to go away and produce something completely different. The CMI model is embedded in a lot of processes, a lot of reporting, and filling with that is not on our agenda unless it makes things better. So here's a quick update on the CMI timeline. You can see from the first line it took quite a long time actually to get the CMI model researched and put into place. So and it's easy now to look back and think that it was all very obvious, but actually that was a fantastic job getting people just getting their arms around what was really a quite thorny problem, and getting a sensible, pragmatic view out there was an enormous achievement in itself. We've gone through various revisions, and if I skip down to the dark blue line, which is the line below that, is consultation meetings, which is what we're kicking off this month. We plan to have some concrete, possibly semi-concrete proposals for a model to review come March next year. And then the scheduled timetable is that we will produce the next version of the model, CMI 2016, in March 2017. And I should just draw your attention to a couple of points there. One is that based on user feedback, we're planning to switch to a calendar year cycle so that we will use the data from a whole calendar year and release the model in the following March, which actually, so it certainly helps with insurers and their reporting. And it's also just nicer just to be able to work. So at the moment we use part year data to feed into the model, and that creates a lot of complexity and additional issues which we'd rather not deal with. So both of those arguments push us towards having a calendar year-based version of the model. I'd also point out it's going to be 1.5 years between CMI 2015 and CMI 2016. So we're reviewing, as part of the Projections Committee, we've got a number of strands of research, and the plan today is just to give you some insight into what we're looking at and what we're thinking about, and give you an opportunity to comment. So I'll just run through these individually. So first of all, we're going to talk a little bit about recent mortality and its impact on projections, because we think that's something people are interested in. And actually, that kind of brings the issue about, I apologize for saying DPV by new information, but that brings it into focus, because 2015 has been quite an unusual year, and everybody's saying, well, what is the answer? How would I even know what the right answer is? How would I assess that? We're going to talk a little bit about data, because if you don't feed in the right data and your model depends on the data in some sense being consistent or correct, you can end up with some odd answers coming out. It doesn't matter if all you're doing is averaging the data and there's a wrinkle in the data, but if you're starting to do something a little bit more sophisticated statistically, then those wrinkles start to show up in the impact on your output. We're going to talk a little bit about responsiveness and stability in a kind of general context, and talk about how we should go about updating for new information. There'll be an opportunity for questions after each strand. Sorry, the final one is me just picking up some other issues. So there'll be opportunities for questions after each strand, and we'll pick up any questions you have that you don't feel have been answered at the end. So just on a note of housekeeping, so when you ask a question, if you could give your name in advance. There are some roving mics, I hope, and so somebody will come around with a microphone, because we'd like to capture everything that people say. So if you could give your name before you ask a question, that would be great. So I'm going to hand over to John Palin.
Thank you, Tim, and good evening. So as Tim says, I'm going to start talking about mortality in the past few years and what that might mean for future projections. Let's start with some data on recent mortality. This is showing deaths in England and Wales from 2000 to 2011. It's for males and females combined. The slightly quirky age range, that's the age range that's used to calibrate the CMI model. In practice, that covers about 99% of all deaths. So we can see deaths have fallen through that period, but there are really two things going on here. There have been some changes in age and gender-specific mortality rates, which we're interested in, but also changes in the population. Over that period, the population has got bigger, and the mean age has increased as well. So we'd like to be able to split out those population changes and figure out what's happened to mortality rates. The first step in doing that is to calculate a hypothetical number of deaths. So what we said for each one of these points is to say, suppose the population was as it was for the very last point in 2011, but the age and gender specific crude mortality rates, deaths over exposures, were as they were in that particular year. So what this is telling us is, if we had the population structure of 2011, but the mortality rates of 2000, for example, you would have had, what, about 630,000 deaths or so. Those numbers in the hundreds of thousands are a bit cumbersome, a bit unwieldy, so we divide by the deaths in 2011, and then we get a standardized mortality ratio. So 2011 by definition is 100%, and mortality, once we allow for population changes, was just over 30% higher back in 2000. We've also drawn a trend line there. The dotted line is an exponential trend line, so it's a constant rate of mortality improvement, and that turns out to be about 2.4%. And looking at that, the dark blue dots look remarkably close to that trend line. They're not absolutely spot on, there's some year-to-year variation, but they follow that trend really pretty clearly. And I think if we were here back in 2012, 2013, looking at that chart, mortality projection would look pretty simple. Obviously, there are some cohort effects and age effects and things, but the basic thrust had been a period of pretty steady mortality improvements, and a plausible thing to do would be simply to assume that mortality would follow that trend. But as I suspect many of you will know, particularly if you've read Working Paper 83, that's not what's happened through the past 4 years. Mortality in 2012 and 2013 didn't show much change at all. 2014 was a more typical type of mortality improvement, about a 3% mortality improvement. And then 2015, obviously we haven't yet got to the end of 2015, but based on what we have seen, we think that that's linked to mortality going up, getting worse by about 2.3%. Subsequently to this, which was accompanying CMI 2015, we've got about 10 weeks more data, but that doesn't seem to be changing the picture much. So 2015 looks odd, and 2011 to 2015, as a period as a whole, looks a bit odd. To try and put those into context, looking at one-year improvements first of all, if we look at the percentage reduction, the percentage change in this standardized mortality ratio, that's essentially a mortality improvement. If we look at that, 2015 at minus 2.3% was the worst in the 40-year period that we used to calibrate the model. So it's exceptional, although it's not completely out of line with what we've seen before. Going back to 1985 and 1993, those are both about minus 2% or so. So 2015 does look pretty odd, though. But to really put into context, looking at a full 4-year period, I think this next chart is the one that's perhaps most interesting. So what we've done here, we're showing the average annualized mortality improvement over a 4-year period. So just to make clear what that means. So the value for 1979 is saying, how has that standardized mortality ratio changed between 1975 and 1979? That was about 3.2%, and then converting that into a rate per year, that was about 0.8%. We've calculated that for all of these periods, and for most of the chart, things are sort of fairly steady. For the first half of the chart, this 4-year annual average was bumbling along at 1 or 2% or so, some volatility, but within a fairly tight range. Getting into the 2000s, it's up at around 1 to 2% or so, but again, a fairly tight range. And then we've got this number of 0.3% for 2015, which looks really very extreme. We had a question when we did this talk in Edinburgh asking us to try and quantify, to put a number on quite how extreme that is. This is a bit of, this isn't massively scientific, but it hopefully helps to make the point. So if I keep those crude points and draw a smooth line through it, if we think about the period up to 2011, those points compared to the line, there's a standard deviation of about 1/3%, relatively small. If we extrapolate that line and put on the last 4 years, we might have expected that line would have gone up to nearly 3% or so. We're down at 0.3. And if we assume a normal distribution, which looked reasonable up until about 2011, that's about a 7.5 standard deviation event. That's about a 1 in a trillion probability. So it's giving a pretty clear message. I'm not saying this normal distribution and this smooth curve is a great model necessarily, but it's a pretty clear message that the last 4 years have been very unusual. So far, we looked at mortality by year. You've seen this chart before. We can also look at seasonal patterns of mortality. So the ONS published deaths on a weekly basis. And if we take a 13-week average, because we're interested in broad seasonal patterns, and we're not too worried about noise from week to week, because a register office is closed, so not so many deaths are registered or things like that. The first thing to say is that the volatility within a year is much bigger than the volatility from year to year. The difference in mortality from January to September, say, is really very big. So this chart's a bit hard to read for that reason. So what I'm going to show on the next couple of charts is essentially dividing the solid blue line by the trend. So we're going to show in a particular week, how did the seasonal mortality compare to the long-term trend? Was it higher or lower, and by how much? And if I do that and stretch things out into 3 rows to make it a bit clearer to read, this is the sort of pattern we get. So typically, mortality at the very start of the year is up to sort of 20% or so higher than the mean, and in the summer it's maybe getting to about 10% lower. And to try and give a bit of context for this, I'm going to put in an average over the first 15 years. So what this blue line is showing is week 1 of that blue line says, let's take week 1 for the first 15 years, take an average of all of those, and that's our point for week 1. Week 2 is the average of that corresponding week in the first 15 years. So that light blue line, it's periodic, it's the same for each year. If we concentrate on the first 2 rows, the first 12 years, mortality never got away from the trend for very long. There are some spikes, notably in early 2000 and early 2009, which are mainly to do with flu. We saw high mortality towards the start of those years, but mortality got back to trend fairly quickly. If we look at the last 4 years, or the last 3 and a bit years, the picture looks really very different. The summers of 2012, 13, 14 and 15 have all got this seasonal mortality quite a bit above trend. And apart from the winter of 2013, 2014, which was fairly mild, it had the lowest number of excess winter deaths over a full 40-year period. We're seeing that mortality has been pretty consistently above trend. So this is suggesting to me that the big negative improvement we've seen in 2015, okay, that was due to winter mortality, but the fact that we're seeing this 4-year period looking so strange isn't just around a sort of short-term period. That's what's happened. What does that mean for projections? One way to think about crude mortality improvements, the data we see, is to split it down into these 4 components. I'm sure you could come up with 5 components or split things slightly differently, but I think this is a helpful way to think about it. Firstly, we think there are some smooth underlying trends going on, things like the fall in smoking over a very long period. And those sort of influences and those trends are what we're perhaps most interested in if we're thinking about a 10, 20, 30-year projection. It would be nice if that was all that was in the data, because then we could see it directly, but that's being masked by some other things. So firstly, there's some short-term volatility. As we saw on the sort of previous chart, winters of 2000 and 2009, flu is a big influence, cold winters and so on. That's a short-term impact, which really doesn't tell us very much about what's going to happen in 10 or 20 years' time. The third one, people give it many different names, Poisson individual idiosyncratic risk. Even if we knew the true probability, because the population's finite, it won't turn out precisely like that. And finally, sometimes we can't necessarily trust the data we're using. Brian is going to say more about this, but this can make it difficult to interpret some of the crude mortality rates. So typically, we want to pick out item number 1, and we want to try and sort of smooth out or remove items 2, 3, and 4. I think 3 and 4, perhaps not so difficult to address, but I think the main problem is pick out 1 and 2 and give them different names. Essentially, has recent experience been a trend, a nice sort of smooth, steady thing that we might expect to continue, or has it been a blip? It's been caused by something short term, and we think it might go away. And I think individuals will have different views on whether it is a brand new trend or purely a blip or somewhere in between, and that might give different views to how to project mortality forwards. I'm going to show 4 possible mortality projections. These aren't supposed to be sophisticated models by any means. They are fairly sort of crude caricatures, but it's designed to sort of give a range of ways that people might think and sort of try and frame the discussion a bit. So on the next few slides, I'm going to show pairs of charts. So on the left-hand side, mortality improvements. So we've seen, as we talked about before, fairly steady improvements, averaging nearly 2.5%, but then lower improvements over the past few years. And on the right-hand side, the similar chart we saw before of standardized mortality ratio. So how might 4 different people potentially view that data and come up with a different projection? One option is to say that we've seen 4 years where improvement has been nil on average. Okay, 2014 was a reasonable improvement. Maybe that was just about a mild winter. Things have changed, things look different, so let's assume nil or very low improvement going forward. So mortality rates have been coming down, but they're now going to be flat. That may be a reasonable view, it may be quite an extreme view, but it's a way one might think. Conversely, you may say the last 4 years, it's short, it's just a blip, we don't really understand quite what the causes are, so it's prudent to take the long-term trend, assume this 2.4% trend continues. And what that would mean for mortality rates, the standardized mortality ratio, they wouldn't get back to the long-term trend, they would remain about 8 or 9% above. So we're saying if mortality improvements follow the long-term trend, then mortality rates continue to be higher, sort of permanently higher than the previous trend. That's another possibility. In practice, a lot of people may say it's somewhere between the two. There's some information contained in the recent data, but I don't want to look purely at the recent data. Lots of different ways you could do it. You could take an average over the last 10 years or something like that. You get something that comes in between. And then the fourth possibility is perhaps a bit subtler. I think probably makes more sense to explain starting on the right-hand side. And that's to say, if we follow this trend from 2011, that would give us a certain view of where mortality rates would be in, let's say, 20 or 30 years. And we may think there are particular reasons why those improvements could have been made. The fact that they haven't happened in the first 4 years doesn't mean that those reasons can't come through in the next 26 years. So if you take that view, we're saying on the right-hand side, we expect that mortality rates, which are high compared to trend now, will get back to trend in the longer term. And in order for that to happen, going back to the left-hand side, improvements have to be high in the short term, higher than the previous trend, and then coming back again. I'm sure you'll all have different views on which of those look reasonable or plausible or not, but I think it's quite striking. In the first sort of 4 or 5 versions of the model, the focus is very much on what is the long-term rate. And I don't think we thought that understanding current rates of mortality improvement was a very difficult problem. I think now, perhaps as the model's gone on, there's been a bit of sort of consensus or herding about the long-term rate, but there's perhaps more of a question about what is going on right now. Do we think this is the start of a trend, a period of low mortality improvements? Do we think it's just a blip, it's going to go away? Do we think it'll bounce back? So in publishing CMI 2015, the committee has been keen to encourage subscribers to think about this question for themselves, and it's something that we're grappling with in our thoughts on the model. How can we come up with a sensible view on this? How can a change to the model or a new model help you with this? So I've talked in very general terms and not about the CMI model specifically. I'm just going to show 2 slides on what's actually happened in the CMI model itself. This first one is looking at mortality improvements. The dark blue line is looking at CMI 2015, which came out recently, and we're showing improvements for men by age in 2012, which is the first year in the model. By comparison, we've gone back to CMI 2012, which used data up to 2011, so that was the last model that didn't have this sort of strange 3.5-year period in it. And to be consistent, we've taken improvements in 2012 as well from that. And to do that, we have to pick a long-term rate, but it's fairly arbitrary because we're not projecting very, very far. If we picked a different long-term rate, that picture would look fairly similar. So what's actually happened in terms of improvements in the CMI model is, certainly if we get sort of age sort of 70, 80, 90 or so, improvements are typically around 1% lower. So the CMI model hasn't said, let's stick with the previous trend and not change at all. It hasn't said the world has changed and improvements are going to be nil. There's been some change, but yeah, I'm trying not to use sort of valued words about whether it's been sensible or appropriate or reasonable or not. You can form your views on that. There's been some change, but it hasn't been as strong as might be suggested by a 0.3% improvement over the last 4 years. And that, in turn, has impact on liabilities. This chart here maybe takes just a short while to talk through. What we're showing is male life expectancy at age 65 for all versions of the model that CMI has published. So if we start with CMI 2009, which is the pale blue on the left-hand side of the chart, that's saying that if you use that model on 1st of January 2010, your life expectancy would be about 22.25. You typically might have kept on using that model throughout that year, and it's gone up a bit by the end of 2010, and then the dotted line is showing how that liability was, how the life expectancy was expected to increase. But then by 1st of January 2011, you would probably have moved to CMI 2010. So essentially we're showing a solid line for the model which most people would tend to have used in that particular year, and then dotted lines for how they would have moved forwards. And I think as you might expect from having seen the data that's used to calibrate the model, there really wasn't very much change at all between the first 4 versions. That level of variation and uncertainty certainly compared with the sort of short, medium and long cohort projections that people were discussing before, the model was really very, very stable. Since then, we've seen some falls, and this is partly confounded by changes to census data and some changes to method that we made in CMI 2014. But overall, over that sort of 3 model period, this life expectancy has fallen by about 2.5% or so. And I'm not going to make any sort of value judgment about whether the model's done something sensible or not. That's the end of what I wanted to say. I'd like to open up for discussion. Feel free to ask any questions on this topic, but just to maybe sort of prompt things, is the 2011 to 2015 experience a blip, or is it some new trend that's starting? I think the big question is, how can we tell? Is there any sort of extra data or evidence or form of analysis that would let us say with some confidence which is true, rather than just sort of a personal feeling or a view? And then I try not to say too much about what I think of CMI 2015. Do you think it's responded broadly appropriately, or responded too much or too little? So I'll throw it over to you. Any questions? Yes, one at the back. Have we got a microphone? And could I remind you to say your name first, please? Thank you.
Sir, Rajiv Shah. Just one question, which is, have you looked at population data in other countries to see whether they've been having any similar effect over the last 4 years?
That question came up in Edinburgh as well. One problem we have is that we're very fortunate that the ONS publish data every week, so we have a pretty good idea of what's happened in 2015. I think I suspect in other countries you might struggle to get data that covers the very recent period. I know the sort of early 2015 period has certainly been bad in other countries as well. Flu has hit various countries. It is something that we would like to do, but I think that's potentially a bit more work than we've done so far in terms of getting the data.
Well, I can recognize limitations on data, on getting weekly data, but I'm just, in terms of the trend that if you call it a trend over the last 4 years, whether you're seeing anything similar in other countries?
I haven't looked closely enough to give you a good answer to that, but yes, I do take the point that would be an interesting thing to do. I think one of the questions we had at the previous meeting was saying, if you compare countries, for example, if you have a hypothesis that maybe reduced government spending has had an impact on this, if you look at countries where that hasn't happened, do they have the same experience, in which case that maybe doesn't help to explain it, or they have very different experience, in which case it might. So no, that's not an analysis we've done yet, but I think it would be of interest. Yeah, Peter. Yes, the microphone's on its way. Thanks.
Peter Manthorpe. Just come back on Rajiv's point. I presented some of this stuff in the US last week, and there the comment was that they were also seeing a slowdown. When you look back over the past 4 years, their main population data is a year behind the ONS, so it wasn't entirely clear. But if you look at their, I think it's 122 cities data, you're quite right. It supports the slowing down in more recent periods as well.
Thank you.
Right, so just to add that there was some good statistics for 2012, where we saw almost every country, I think every country in Europe took a dip at the same time as us. But I haven't seen anything for the whole of Europe since then.
Okay, thank you. And Richard.
Richard Woolett's partnership. I thought that was a really good explanation and analysis of the recent trends, John. I suppose my kind of question is just, have you analysed how it varies by cause of death to see whether we're seeing the pace of improvement in particular causes sort of dropping off or being sustained and so on?
It's not something we've done yet. Yes, I think when cause death data for 2015 comes out, which I guess is about a year's time or so. Yes, I think seeing that there are some causes like cancers where you wouldn't expect much sort of seasonal volatility, sort of respiratory disease that you would. I think that will be an interesting analysis, but no, I haven't done that yet. And Joseph.
Have you looked into the differences in ages?
Yes.
Any age groups that are more problematic than others in those 4 years?
Yes. So improvements have been worse it's been a bit worse for females than males, and at older ages in particular, they've been affected much worse. So I think we saw sort of. Sorry.
Is it 75, 80?
There's a fairly sort of steady slope almost. So yeah, as you get older and older, the improvements get worse and worse. Anyone else? Yes.
Jim Webber. Firstly, one observation. The data for 2015 clearly does include a blip. I mean, I don't think there's any doubt about that. There's very high influenza deaths. And I guess, wouldn't it be nice to try and develop the model and analysis to try and sort of normalize influenza deaths? That would seem like a good improvement. Also looking at some of the very nice graphs in CMI 83 and 84, listening to your presentation today, I was struck by how much of your analysis is based on treating 20 to 2010 as kind of normal. I think if you went back and did that analysis over, say, 40 years, the experience we've had over the last 2 or 3 years would look actually much, much closer to your trend lines. Now, that doesn't mean that the trend shouldn't change, but it just means that it might not seem quite as extreme.
So, taking the second comment first, I do take the point that mortality improvements were very high in the 2000s, but if I go back to this chart, this is looking at 4-year improvements going all the way back over a 40-year period, which is about as long a period of data that we think is credible and trustworthy. And the last 4 years is definitely the most extreme on that one.
It is. There's another nice chart you showed where you just looked at the year-on-year, not annualized, annual improvement.
Yes.
And you look there, if you'd used the previous, 25 years to 2000, what kind of 1 in n probability would you come up with for the following 10 years?
Yeah. So, I mean, crudely, just by eye, it looks about maybe half the number of standard deviations. Maybe we're looking at 3.5, 4, which is it's still
just about every year. Just about every year, year after year.
Yeah.
So I think we do need to look over longer term. Is my key point.
Yeah. Just to pick up very briefly on the flu point. Yes, that is a thought that has occurred to us. I think the challenge of coming up with a credible model of quite how many of the excess deaths were due to flu or cold or something else. I think a causal model might be a challenge, but Steve Bell is going to talk about a model which does look at splitting out year-by-year volatility from long term.
There is some public data on this. Okay. I'm afraid I can't tell you where it is, but I happened to come across it last week.
Okay.
How credible it is, I don't know, but it does exist.
Okay, thank you. Yes, a question over on the far side.
Hello, Mark Pawson. John, looking at that slide in particular, it looks to me quite stark that you can sort of split the first half from the second half, building on a similar point to the previous one. But I wondered if the committee has considered looking at, or if you're aware of any other research which looks at what might have caused the kind of step change in the late 90s that there looks to be there, and whether that might give any guidance as to whether there's maybe a similar sort of step change in the other direction that's just happened around now.
I guess a cause of death analysis of the type that was mentioned earlier. I mean, that would potentially be of interest. So there's always a question about how predictable that would then be. But yes, I don't think we've done that sort of analysis, and to be blunt, I don't have a good sense of why why the last 4 years has been quite so extreme. How are we for time, Tim?
You got 2 minutes.
Okay, we have time for some more questions if there are any. Okay. Yes.
Hi, Daniel Haxby. The way you drew the 4 different possible trend lines,
yes,
they all look very plausible to me. Well, it makes it look like picking a short-term trend rate look fairly spurious, and it makes me think you might want to do something stochastic, which allows for a lot of trend rates, rather than trying to pick a short-term rate based on flavour of the year.
Thank you. Yes, yes, I don't think any of those. Well, don't think any of those necessarily look completely ridiculous. I'd agree with you. There's certainly a range of views there. Yeah, I think in terms of whether the CMI model becomes stochastic or not, it's something some people have mentioned to us, but I suspect the degree of complexity, whether that's something that many users would want, that's something we'll need to consider. Thank you.
So it might just be worth noting that the topic that Steve is going to talk about is effectively embodying a stochastic model in a standard framework. So we're very alive to the comment you've just made, which has definitely occurred to us as well.
Yes.
Hi, Bronwyn Lusby. You said that the excess deaths were more at older ages. We know that the ONS and the CMI estimate population at older ages. How much do you think we might be mismeasuring these rates based on that?
I'll duck that question if I may, because the next section is going to talk about that. And also, I guess you may have seen the High Age Mortality Working Party that Steve Bale has chaired. Yeah, I think sort of the data that we've been, so my comment response to Joseph was maybe sort of going up towards those sort of older ages, so getting up to age 80, 85 or so. There is that sort of trend. I think you're right to say there is uncertainty at maybe age 90, 95 plus. But I don't think that's greatly affecting the sort of results here, but in the context of a standardized mortality ratio, simply because there aren't so many people there. Okay, I think we'll stop there. Thank you.
Hi. I'm going to give a very brief sort of recap and overview of sort of where we are with the data that feeds into our current model, which may be familiar to some of you. We did some presentation, or we did a presentation last year at Staple Inn, sort of early last year, where we highlighted and discussed some of the data issues that we were having with our model. In particular, we talked about the issue of over-dispersion, where the sort of variance in the observed data is sort of in excess of what we'd expect given our fitted model. And we highlighted some of the areas where this was sort of particularly evident, and one of these is in the sort of familiar sort of strong diagonal line that you can see on this chart here for the 1919 and 1920 cohorts. And we showed last year as well that if you follow that through into our modelling, that that strong diagonal pattern, as it follows through into the residuals from our model. And so this was one of the areas we particularly highlighted our concerns around over-dispersion. Around a similar time as our talk, I feel I'm getting really close to that. Similar time as our talk last year, there was a paper published by Cairns, Blake, Dowd and Kessler. And in that, they went into quite some detail over a couple of the issues that particularly affected the ONS data, which were related to the assumptions made about the distribution of births. And they highlighted the kind of effects that those assumptions could have and the kind of discrepancies that they could have in our exposure data that we're using in the model. And so as well as describing the problems and suggesting specific adjustments that they could make for those particular issues, they also went on to describe a more generic method, a sort of Bayesian Monte Carlo approach that could be used to clean any data set without knowledge of the underlying data issues, but based on certain assumptions around the smoothness of rates. This did come out before CMI 2014. We didn't go as far as adopting the Bayesian approach suggested by the authors, but it did at least give us the confidence that the issues we'd highlighted in the data weren't true reflections of the underlying experience, and they were, with all probability, sort of data artifacts and data issues. So what we did for CMI 2014, so we didn't adopt that proposed method. We wanted to use a method that was much more pragmatic and easy to describe to our users, and so that users could replicate as well. Effectively, we just fitted our model twice. We, after the first run, we identified the most extreme residuals, which you can see highlighted here. We adjusted the exposures for those cells so that the raw mortality rate equaled the fitted mortality rate. And then we refitted our model effectively using this adjusted data. Since then, we have gone back to the Phantoms Never Die paper, and we've tried to look at the specific ONS issues that they highlighted. We have, I've not got it to show here, but we have sort of done some modelling work on those issues, and they do a really good job of cleaning up that very strong 1919 and 20 cohort line up until around the mid-2000s. And then there's still a remaining strong pattern in that area, which does coincide with where our approach was having the most effect in that top right-hand corner. So we're now trying to look at other potential issues, try and help explain that area, which we could combine with the sort of issues pointed out by Keynes and co. And one of the issues which was just mentioned, of course, the 1919 cohort entered the 90+ group in 2009. And as was mentioned, that we mirror the ONS's approach to producing estimates for the population estimates at above age 90. There's still question marks over that approach. When we apply that, there's some very big adjustments needed to tie back in to the ONS's original 90+ estimates. And there is potentially still some issue there related to the issues raised by Keynes and all in terms of the distribution of births, although it doesn't look like it's going to be such a big issue as the ones that they highlighted. So that's certainly one area where we're looking to investigate. Wrapped around that idea of the 90+ method, as I mentioned, there's still a big adjustment needed to tie back into the 90+ aggregate figure that the ONS publishes. And one of the ideas we've had is potentially using a lower threshold and seeing if you apply that method with a lower threshold, not quite sure how far down you'd go, potentially having a lower adjustment to tie it in, and then having more confidence in our data. I think that relies on the assumption that the data on deaths is more reliable than the data on population estimates, which is, I think, generally accepted. But there are still issues with the high age data. I mean, you're assuming minimal migration if you're using that sort of canisto-Thatcher type approach. So I'd say these are the type of areas where we're planning to look into next. I wanted to stick up a couple of questions to sort of try and produce some comments and suggestions. First of all, do people think we should be concentrating our efforts on trying to effectively fix the ONS's data that goes into our model? As the model stands at the moment, it will give us much more comfort in the model, and it does tie in with, again, it was all previously mentioned, the High Age Mortality Working Party, who released their paper last week, ties in quite naturally with that, so it seems like a natural next step. Or do users think we should be going down the more generic route? I don't know, if people are starting to use the model more in other territories where we're not aware of specific data issues, should we be looking to incorporate a more sort of generic adjustment within our model? So as I say, that was a quick recap of what we've looked at in the last year and what we presented last year. I'd be interested in any comments, answer any questions. Down the front.
I have a question on something more fundamental than that, which is what do you do with the latest census? Because my understanding is all these exposed to risk hinges on every census every 10 years, and and every single numbers between them are derived numbers. Do you go back to readjust and reset all the estimates?
We've used, although in the model we use the ONS's published estimates, which are rolled forwards and also rolled back for corrections. One of the issues in the Cairns paper was particularly over the 2001 census. And when we looked at that, the authors had suggested an adjustment to apply in 2001. When we looked at the adjustment for that, we tried to mimic what the ONS would do by sort of rolling back the adjustment as if they were spreading back the errors, which they do, and then also rolling it forward. So we effectively spread that adjustment 10 years either side. Because the remaining issues are in that sort of top corner still, in the far right corner, we do want to look at the 2011 census as well. Andrew Cairns suggested that it didn't look like there was a similar issue in that issue, but because that's in the area where there's still remaining issues, we still want to investigate that. But we don't generally recreate the whole exposure set ourselves. We generally use the ONS's published figures. Anyone else? Comments? Good. No? Can save some time and I'll hand over to Matt.
Hello. So before I start, it would be remiss of me not to credit Stephen Rimmer, who did the majority of the analysis that follows in this section. In this section, we'll focus on two key questions. The first is, does mortality experience exhibit a pattern over time? That is, if we know the recent history of mortality rates, does this help us to predict subsequent observations, or is it just a white noise process around a trend? The second question is based around our primary aim with the mortality projections model is to predict future mortality rates, not to describe past rates. And we want to consider further whether this distinction should affect how we build the model, and in particular, whether this alters our view on the degree of smoothing we should apply. And to help draw these points out, we've looked at how they apply to a straightforward model of mortality rates and improvements, and for ease, we've used the simplest Lee Carter model and fitted it to various data sets taken from the human mortality database. So for question 1, we fitted our model to England and Wales male data. The form of the model is shown in the equation at the top left, where we can see that the log mortality rate for a given age in a given year can be described by 4 components. So the alpha is the age component, which can be thought of as a base or reference log mortality rate for each age. Then we have beta and kappa terms which work together. The kappa encodes effectively the overall level of mortality for each year, and the beta is the relative sensitivity to the kappa at each age. And then finally we have the epsilon term, which is a residual term. And the chart shows the progression of the kappa values over time when we fit the model to the England and Wales male mortality data, and we see a fairly familiar pattern of modest improvement over the first part of the 20th century, followed by a steeper curve in more recent years. Next, we add a trend line in gold here to the raw output. It's a forward-looking trend line. So what we do is we look at the linear trend in a given 5-year window. We then, the gold line is then that linear fit extrapolated to the next year after that window that was used for the fitting. And it can be viewed as effectively the kappa that you might have guessed for any given year based on the information that you had available leading up to that point. Next, what we can do is plot the difference between the raw data, the blue dots, and the gold line. And in this chart, we've re-expressed everything relative to our naive projection. So effectively, the gold line goes to 0. Next, what we do is to investigate the properties of this series. So the top chart here shows the autocorrelation at increasing lags, and the bottom chart shows the partial autocorrelation. So that's the correlation between terms in the time series once we've allowed for the correlation we've already got in the terms with lower lags. If we look at the top chart first, we can see at lag 0 what we're doing is working out the correlation of the one. We can see in consecutive terms. This means that if the current point is above a projection of the recent trend, there's a greater chance that the next point will also be above trend, and vice versa. If we're below, then we end up below. The pattern is less clear at higher lags, but if we take the two charts together, we can see some evidence of negative correlation between more distant terms. And overall, we see that we don't have a memoryless process. So that is, knowing what's happened in the recent sequence does help us to predict subsequent terms using this naive model. The previous slide's analysis was looking at log mortality rates. And if we take this on a step, on this slide we look at the first difference of that series. So that's akin to looking at mortality improvements relative to the recent trend. And if the log mortality rate were simply a constant trend plus white noise, which we've seen it kind of isn't, then the first difference would be a simple moving average process which would have autocorrelation at lag 1 of -0.5. What we can see in this, or the two charts in fact, we do see negative autocorrelation at lag 1, as we might expect of these first differences, but it's not as strong as you'd expect for a pure white noise process. So effectively what we're saying is that our naive projection doesn't give us a particularly good model because its output is not memoryless. And based on the pattern of recent data, we know whether the next data point is likely to be above or below trend. And so we also know whether the next year's change in projection is likely to be up or down. So by analysing the sequence of kappa values, we've had a look at our first question. To address the second question, we use the same model, but we focus on the beta term, which represents, as I mentioned, the sensitivity at each age to the change in the kappa values. So again, we've got the black dots, which are the raw outputs from the model, and we can see a general downward trend with some noise around it. There's then an element of judgment in how to use this information, so how much smoothing of the raw results will give us a useful and usable model. The first tool we could use to help us to decide what we're going to do is to use an information criterion type test. And then the second is a test of the ability of our model to make predictions outside the window in which the model is fitted. Just as a recap, information criterion models are extensions of the log likelihood tests, but have an explicit penalty for the number of parameters that you're using in the model. So as you increase the number of parameters that you use, you've got more flexibility to change the shape of things to fit your data better, which would increase your log likelihood. The aim of the penalty in the information criterion tests is to indicate whether the fit has increased enough to compensate for the extra flexibility that you've afforded yourself. For this analysis throughout, we've used the Bayesian information criterion, or BIC, and it's just worth pointing out before we move to the next slide that due to a sign convention, if we have a decrease in BIC, that means that the test is saying that the addition of the additional parameter would be supported by the test. So what we did was we calculated BIC for 13 countries based on human mortality database data. And what we did was we took a sequence of 40-year windows and a range of polynomial fits to the raw data. We're taking the linear fit, which is the blue dot, as our base starting point. And then we've shown as the other dots the difference in the average BIC across each 40-year window for each of the polynomial fits. as I mentioned earlier, we want the BIC to decrease if we're getting better models. So we're looking for coloured dots that are below the 0 blue dot line. So for Australia, which is the first country that we've got here, we can see they're fairly tightly together. We can see that the linear fit gives us the best model. For Spain and Finland, the gold dots are the lowest, so sort of halfway across. And where's Spain? Yeah, Spain is about halfway across, and then next to it is Finland here. It's difficult to see with Finland, but I believe the gold one is slightly lower. And for all the others, the cubic or quartic fits give us the best model. So effectively what we're saying here is that the Bayesian information criterion is giving us a relatively complex fitted model in most cases. For our next test, we take the same countries, we take the same 40-year windows, but instead of using this BIC, we are looking how well each polynomial fit to beta performs in predicting average period life expectancy for the 10 years following the 40-year window that we fitted to. So looking at how our predicted numbers, compare to what was actually observed in that later 10-year period. And again, we've taken our linear fit as our base case, and we've shown the increase in life expectancy prediction error compared to the linear fit. So basically that means that the chart is the same way up. We're showing the same thing. We're looking for the lowest dots to give us the best answers. And under this test, so this sort of predictiveness test, as it were, we can see that 9 of the 13 countries, in most cases, we've got a blue dot lowest. So it's saying that our linear fit is performing best in out-of-sample prediction. For 3 cases, we have a quadratic fit as the best. You can sort of see those, where are we? Canada and Spain and France. And for the last case, which is Australia, again, the dots are very close together, but the quartic fit is actually very marginally better than the others. It's worth pointing out just here, we can see the linear fit is better in many cases, but we can't just say that the simplest model is always going to do the best. If we look at Spain in particular, actually the difference between the quadratic model and the linear model is quite significant. However, when we do compare the 2 charts, there is only one case where a more complex model is supported by the prediction test than the BIC test. And in 11 cases, the prediction test suggested a simpler model than the information criterion test, suggesting that when we're looking at prediction, a simpler model is often better for predicting than a more complex one. So returning to and sort of developing our original 2 questions. Firstly, does mortality show a pattern over time? Relative to our naive model, the answer is yes. But because the next result is not equally likely to be above or below our prediction, so the model update as we include the next data point is not equally likely to go up or down. And because autocorrelation in the data relative to the model feeds into the prediction, that means that the series of predictions from our naive model is itself autocorrelated. Clearly, this isn't an attractive feature in a model used for projecting cash flows and valuing liabilities, because you're able to guess which way it's more likely to go. The current CMI model has a couple of features to guard against this. Firstly, we smooth the observed mortality rates, and secondly, as I'm sure you're all aware, we step back inside the smooth data, and both of these reduce the risk of undesirable edge effects. But there are some questions, obviously, for further discussion in relation to the CMI models. Firstly, is smoothing the best way to go about this, or could we consider or justify a more explicit approach? And if we wanted to do that, what would that look like? Secondly, if we think smoothing is the appropriate approach to reduce the risk of unwanted autocorrelation, does this impact our view on how much smoothing we should apply? And this kind of leads then onto the second question, which was how much smoothing we should apply to improve the predictiveness of our model. Again, compared to the naive model that we've the toy model that we spoke about, the current CMI model does guard against overfitting somewhat by using a quasi-Bayesian information criterion. So compared to the standard BIC, it tends to produce a smoother fit by making allowance for the overdispersion that's observed in the data. But the question remains as to whether using a greater degree of smoothing still in the model could improve its ability to predict future mortality improvement rates in the near future. And certainly a greater degree of smoothing would have the additional impact, potentially desirable impact, of increasing the model's stability from year to year. But on the other side, it would reduce the ability of the model to pick up a genuine change in trend. As discussed by John in particular, recent mortality experience has brought this trade-off between stability and responsiveness into particular focus. And again, your views, comments, suggestions, welcomed.
Richard Willits. When you measure sort of autocorrelation in the raw data, do you find that result depends upon the period that you do the analysis over? There seems to be a lot less volatility in more recent data. Does it sort of give you a different result if you look at the sort of last sort of 20, 30, 40 years compared to the longer time series?
I think that is true. Sorry, I'm just sort of looking across to other people that did a little bit of this stuff. I think that is true. I mean, one thing we did do, which isn't looked at in here, is to look at autocorrelation in other countries, and we do see similar things in there. But I think looking over, trying to remember whether we did actually do that analysis. I have a suspicion that we did, and we did find to some extent what you say. But I think the result generally seemed to hold across time periods and across countries, albeit obviously with some variations. Make life easy.
Joseph Liu. What role does the cohort effect play in this analysis? Because it used to be a burning question, and it has big financial implication. Is it all gone now?
I think we deliberately haven't focused in any detail on the cohort in this particular bit. This is sort of more to have a think through the ideas, but I think certainly a deeper dive into this would involve sort of more of a look at cohort effects and so forth.
I think the punchline to this session is that there's a cautionary note against overfitting. Fitting using information criteria in particular might lead you to select a model, but actually when you go and test it by trying some sort of cross-validated method, you find that it's not actually genuinely predictive. So we are dipping our toe in. So there's a bunch of things that you've mentioned, Joseph and Richard, that we haven't, confounding factors that we haven't pulled out of this. It's really just saying that if we try and fit stuff with a statistical approach, there are lots of traps, and we wouldn't want to dive in saying, look, it's got a massive AIC or BIC score, and therefore it must be right.
I mean, there's certainly stuff in the literature to suggest that if you want to predict better, actually, it's not just for mortality, for other things as well. If you want to predict better, it's not necessarily good to have a complex model that fits the data perfectly. It's actually good to have there's a trade-off there between fitting and simplicity. Sorry, there's a question over here.
Phil Simpson. You used the Lee-Carter model for testing for the various correlation effects. Did you investigate whether you get the same results using a different demographic model?
We didn't. We just simply used the simplest model we could think of for the purposes of the calculations. Again, it's something that could and potentially, arguably, should be done. I suspect you'd find something similar, but I couldn't say for sure. We good?
Are there any more questions? I don't think so.
Can't
So I
say
think
anything.
we just want to caution, if we come out with this, eventually come out, oh my gosh. If we come out with a simpler, quite a simple model, at the end of this, that's good. If we come out with a simple model, then there might be some reasons for that, which is that overfitting is something we would be working against. And just because you get a fantastic fit to past data doesn't mean that your model is predictive. So I think it's striking it. We're sounding a note about simple models might not be the wrong models to actually end up with. Thanks, Ben.
Okay, so in this session, we'd like to share with you a research strand the committee has been working on to consider how we might best update for new information. Before I jump into mortality, I'll kick off with a simple example here. So what you have here is a moving object. You've got two charts. The x-axis is time. The y-axis is distance. And you can see that, and so you've got the blue dots measuring the position of the object at each point in time. You can see it jumps about a bit, but then comes to a halt broadly around 100 meters. And so we've got a question here. Do we follow the left-hand chart, where we're placing more emphasis on the measurement, on the observation, so we follow the observation quite tightly? Or do we follow the right-hand chart, where we place more emphasis on the prediction? So it might be that the system has got a lot of noise in it, so we may react more slowly to that. So now I'd like to introduce the concept of Kalman filters. So Kalman filters is named after its inventor, Rudolf Kalman. And in doing so, we've relied quite heavily on work by Durbin and Koopman. If I talk through the flow chart, so what we have, if we start off at the sort of top right-hand corner, we have a prior view. We have a state vector that describes all information about this moving object. And for simplicity, let's just say that the core information can be reduced to position and velocity. So we have information about the state vector, we have information about its uncertainty. And so given that prior view at time t-1, we can then predict what the observed position might be the next time step forward at time t. So what you see as we move to the bottom right-hand corner, and we've got those predictions for state vector, the uncertainty, and then the observation at t, given our information at t-1. We then move forward in a time step to time t, and we get an observation. And then, as a result, our state vector is updated, and so is our uncertainty. And then we can use that information then to predict forward what our observation might be in the next time step, and so on. So we work through time steps. If we now move into mortality, so what we have built is a prototype model that has an age, period, cohort, and a noise structure. We've modeled log of mx. We've used constant, linear, and quadratic polynomials to model the age, period, and noise effects. And then we've used basis splines for the cohort effect. Underlying that, we follow a position velocity and also an acceleration form of model. For position, it's the current level of mortality. For velocity, it's mortality improvement. And then for acceleration, it's that rate of change in mortality improvement. So what we'd like to share with you now is this proof of concept model. We focused on fitting the historical data, the data that was used for the CMI 2015 release. We present them for males, and we present the heat maps. So we released a heat map tool, working paper 82. So these heat maps draw heavily on that. Had to get the plug-in. First of all, I'd like to present to you the heat map for the current CMI 2015 model for males, long-term rate of 1.5%. Hopefully many of you are familiar with this. I think what I'd like to call out as we step through the results is that we've split the chart into two parts. Despite me saying this with the solid black lines across the screen, to the left of the dotted line is the historical smoothing, and then to the right we've got the future projection. So I'd like to present to you first of all the mortality improvement heat map from our Kalman filter. We've included both age, period, cohort and noise. We have focused on ages 60 to 90. So a couple of features I should call out. I'm actually going to start with the right-hand side first. I stress that we've focused on the historical element. So the right-hand side, the bottom right-hand triangle are cohorts that we haven't analysed because we focused on historical cohorts aged 60 to 90. And then the top left-hand side, I'd stress with caution, it's an extrapolative projection. So we'd have to consider how we might allow for the future projection going forward. But if we look at the left-hand side, so the left-hand side is the historical smoothing. Hopefully, if you look at it carefully, you can see some diagonal elements, which were evident in the previous slide. But equally, at the same time, what you're also seeing is some quite strong vertical short-term noise components. What we've then done is, because we've got this ability to take out the noise component, we've done just that. And so this heat map shows just the age, the period, and the cohort components. It's still got, so you're starting to see features that are quite similar to the CMI model heat map from 2 slides back. There's still a bit of period effects still appearing quite prominent, and possibly there might be some noise that's still coming through within the period component that we haven't yet been able to isolate out, but it's looking closer. So one advantage of the approach we've taken is that we're actually able to split out the mortality improvements into the 4 components. We're able to decompose them and actually explore them, seek to understand them. So we've been able to split them out. So going clockwise, the age component, the period component, the noise, and then the cohort. It's also quite interesting when we compare this to the approach that we take for the current CMI model. The age component is predominantly a horizontal constant component within our model, the period vertical, the cohort diagonal. And then, of course, we've got the noise component, which you can see split out as a vertical short-term component. We're seeking to understand some of these results. They are initial findings. It's quite interesting, the age component that we're seeing here. I talked about it being a constant horizontal effect in the CMI model, but if you look at this, look at the chart in the top left-hand corner, you are seeing a lot more layering within the heat map. So potentially there could be some age gradient by calendar year, which we could seek to potentially explore further. The period component we see as vertical. The cohorts, we are still seeing diagonal shapes there. And then we've got the noise component for the short-term variation. We've also looked at the deviance residuals. So this is the difference between the smooth results and then the raw data. So we've got the 3 plots going from left to right of the CMI 15. We've then got our model with noise excluded, and hopefully you can see that the first 2 charts are actually fairly similar at first glance. And then you've got the one on the far right with noise included, and you can see when the noise is included that you are seeing a lot lower level of residuals. We haven't got rid of all the residuals, however. Hopefully on the 3 charts you can still see the orange shape going from bottom left to top right. That's the 1919-1920 cohort that we've previously discussed, and that feature is still evident within our data. So this research strand that we've been performing, we've been considering the potential pros and cons of following this approach. The first one is that it does provide a validation of the current CMI model. We are able to differentiate the variation in improvements between the short term through the noise and then the more long-term effects. And our model is set up for the projection element. We could overlay it within the current CMI model projection or another projection should we choose to. We're considering the stability of historical improvements. We're considering data sets as we progress through time in England and Wales, but we may also be considering other appropriate data sets just to test to see how the model responds. We have a single consistent framework that analyzes historic, current and future improvements compared to the current framework, and we are able to quantify levels of uncertainty. We've shown to you that explicit allowance is made for annual noise as well. At the same time, we do recognise this is a step change in the level of complexity for subscribers, and it's certainly something we do have to consider. So as we move to the discussion, we'd be very much interested in your thoughts in terms of this research strand. Has it got mileage? Has it got legs? Is it an area that you'd like us to explore further? So I'm happy to take questions.
Thank you. Joseph Liu from Legal in General. Could you go back to slide 60, please? I think that's a very interesting slide. I'm just comparing age. I think I welcome any model that tries to shed insight into historical components of different drivers for mortality improvement. I just have a question on whether we can have also overlay some scientific understanding and explanations of what we observed here statistically. For example, in age comparing age and cohort components, it looks to me that historically we are seeing negative mortality improvements for age components for higher ages, age 80 plus, compensated only by the cohort components in the positive ranges. So is it something that we can defend if we were to go out and say that historically the period components for the older people is actually negative, were it not for the positive effects of the cohort components? Yeah, just a question of how does it reflect reality, and is that reality, can we explain that reality?
Yeah, so we haven't, Joseph, thank you for that. So we haven't at this stage sought to dig further into some of those components. I think you make a good point about the high ages, and it's something we could look into either the medical side or even, I appreciate it's not below 90, but there have been issues around some of the population estimates for particular cohorts and the high ages in particular. So we could seek to understand if there's anything going on that side, yes.
Peter again. So period component and noise component, how arbitrary is the model construction for the split of those two elements? Because clearly the period component is, you're forcing a level of smoothness in there, and then the volatility comes through the noise component.
Yeah.
So how much is that user defined and thus arbitrary?
That's a good question.
I try.
So Peter, at the moment we've just chucked a model with a lot of parameters at the data, said, does a Kalman filter give you even something even vaguely sensible? So in relation to Joseph's earlier question, we haven't built in, and there's a tension between building in structure that you've got from the past into your model and then locking it into behave like that in the future. We haven't really delved into that level of detail. And so some of this split is fairly arbitrary, and I'm looking at the top, the deep blue at the age component. But at the moment we're just saying, what happens when you apply a Kalman filter, and then we need to delve further into the structures. This isn't really a predictive model. We don't have, so in the sense that, say, a Cairns-Baghdad M7 has a structure, we have a broad structure, but frankly, it could be over-parameterized. We haven't done that investigative work. If we persist with this strand, then come March, we'd be hoping to have answers to these questions which actually stand up to scrutiny and would be robust. So at the moment, it takes, because moving to Kalman filter is actually quite a change in mindset. Stick everything you know in one vector. You're not allowed to cheat, look forward or look back. That's quite a big deal, and we're just kind of trying to get to that point and move forward from there.
Fair enough.
Now, I wasn't sure about the various discussions, but the issues that are raised, they appear to be saying that we are trying to come up with a predictor model, because I don't think that is what we have been trying to do here. I thought we want a descriptive model of the past, and then the prediction is quite simple in the current format, core parameters, and so on. So I just like to understand where we're driving towards. We want a predictive model.
I like the fact that you described the CMI model as simple. I think, bear in mind, but we have to go through quite a lot of rigmarole to even get to the future projections. We take the improvement surface, then we break that down in a way that is not the same as this, but there's it's analogous in the sense we break it down to age period cohort components, reallocate the residuals in kind of a semi-pragmatic way, and then we roll the thing forward. And all of that is quite complicated, I think I would suggest. In terms of predictivity, I think we're not the answer to the world, the universe, and everything at the CMI, but what we're trying to, if we don't provide you with something which looks prima facie sensible, then it's very difficult to move for that to provide a framework in which you can do your analysis or describe your projections. So I think it has to be reasonably predictive in some way. And so I think, although this is consultation, I think mentally we're actually thinking the opposite of what you said, which is that the model should actually demonstrate some past behavior that is sensible. That is, if we look at 10 or 20 years of data, I understand the world's a complex place and the cohort effects, but it should have some sensible relation to what happens next.
Is there a difference between short term and long term? So we want it to be doing something sensible in the next few years, and then it's parameterized much more beyond that, and choose predicate as well.
Yes. So actually, we're all ears on that. If you say, well, actually, what we need is X, and we don't care about this other stuff you're talking about, then fundamentally, there's a bunch of people in this room whose organizations effectively pay for the CMI, and our job is to provide you with something which is technically competent but meets your needs. But the direction which I think we're going is to have something that has at least been tested for predictivity. I'm not saying that's going to be a fantastic test or a test that leads us to a single identifiable perfect model, because I really don't think that's achievable, but something which stands some of that robustness testing.
I'm sympathetic to the issue that you have raised, Matthew, about
a good fit of the past may not be a good predictor of the future. I think this is very relevant if we are choosing a model, like is it going to be Lee Carter or Lee Carter variance or common filter to fit the past and then forecast it into the future. But I thought we are not doing that, so I'm just wondering whether it is as important an issue to consider, and whether we should focus our attention on something else, which is how well the model can describe the past, so that we can use a few simplistic parameters. I know there'll be a lot of work to put into this to just describe the past competently, but for users, especially some people may still just want to enter 2 or 3 parameters to describe the future.
Certainly like a simplified, parameterized way of getting a handle on what's my future prediction. But as John said in his opening session, one of the things we struggle with is actually what is the current trend, 5-year trend, given the data we have. And we'd like something to hang our hat on there. We're not saying that you can't then go away and say, I don't think CMI actually know what they're doing. We're going to do this completely different thing. And maybe there should be scope within the model for you to do that. But we are trying to get, even that is quite difficult when you affix your starting point to a hard surface. And the P-splines flip up, and we have potentially volatile. So we're trying to get to that, but we don't have fixed views at this stage. And this is one, so Steve's strand of research is just one strand. And I think I'd just make the other point, which is that Lee Carter, you can fit into a Kalman filter framework. This is a Kalman filter framework gives you some clarity on what you do and don't know. You're only allowed to know the things in the state vector. And
thanks very much. I also know that the US have chosen a different method of fitting. I'm just wondering whether you could put that into the whole consideration that you are.
We are liaising with the Society of Actuaries. Sorry, we'll come on to that. But we talk to the society as well.
Hi, I just want to comment on some of these charts really naively, but hopefully then you'll be able to help me understand them. But if I just look between 96 and 2010 in the period component, so there's a really strong period component there. So if the cohort so let's say the cohort effect really exists 1919 to 1920, that diagonal line always is going to be there. And this filter's just split that. Yeah. It's just split that really strong cohort effect into a weak cohort effect with a balancing negative one, a really strong period effect, and a new idea that there might be some age component, which is negative at high ages and positive at low ages, and which is really, really interesting. But I think, and I guess I do think you should continue this line of research, but my concern would be, say all of this is true, how am I ever going to know the period component in my prediction? I mean, how is it going to help me predict? If you say, okay, well, I think the cohort component is probably weaker if I look at the past and say there was a really strong period effect here, but how am I going to know what my period effect is going to be in the future? So that's just my question. How is it going to help me build a predictive model? But I think that maybe comes back to the questions that were asked earlier, saying, how do you know the difference between period and noise? And you were saying you were going to investigate this. But I guess I would say that we do want to be focusing on a predictive model, and those are the questions that I think you'd want to be able to answer.
So we now, so most of this, so this has been on, as you've seen, seeking to get some results from a historical side. You're now potentially saying, well, how do we project these various elements forward? That's something that we do have to think through, and we'll consider that as part of the consultation.
I'd also say in the slide that Steve showed you with the process of running the Kalman filter, somewhere in there's a linear transformation that takes a state vector from year 1 to year 2, and that is whatever you end up with in that matrix or that linear transformation is how you predict the future. That is the model. So if that's a good fit to the past, and be cautious about overfitting the past, then that is your predictive model in effect. That makes sense.
Got a question over there.
Hi, it's Martin Lowes. I just wanted to ask a dumb question because I didn't understand at the beginning. The first slide in this session showed a choice, or theoretical choice, between following the data very closely or following the prediction more closely.
Yeah.
In my mind, that looks like how much do you smooth. Maybe it is, maybe it isn't. It wasn't clear when you moved on to talking about how you apply this method to mortality data. Are you making a judgment as to how closely you follow the data as compared to how much weight you put on the previous prediction? Or is the Kalman filter itself training itself from the data as to how closely you follow the previous trend? So is the model telling you how much to smooth, or are you feeding in some parameter that tells you how much to follow the data or how much to follow the prediction?
Sure. Okay. So just to revert back to the beginning of the presentation, ultimately I'm presenting on results on this slide 58, where you're seeing all components included together. So this is where you're following the observations quite closely. Or on the following slide, which is where you're stripping out the noise component and you're maybe following the predictor. So that's really a decision for the users in terms of which approach they do. And fundamentally within the model, you could also play around with the parameters to achieve the level of smoothing that you're more comfortable with. We're raising this as a comparison of two potential ways you could go down. And the Kalman filter enables you to split out that noise component if you did want to, say, strip it out and actually work through the noise and look to see what your predictor might look like.
But in answer to your question, Martin, I think that the smoothing has actually been carried out, I'm going to guess, by an optimization of likelihood, or so it's actually been fitted to the data. So that smoothing is a consequence of the fitting of the model to the data.
Yeah.
So we haven't sat there and said, I will turn the dial up or down. So there's no judgment yet.
Stephen.
Firstly, thank you, Stephen, for the excellent presentation and the interesting new method. I'd perhaps like to make a couple of observations, if I may. The first is I'd like to echo Joseph's comments from earlier that if we're going to look at increasingly more complex methods and ones which I imagine as a profession we will have to do a reasonable amount of head scratching to get comfortable with, please can whatever we produce as the output of this work pass the sense test. And by that I mean not only can we communicate it to the rest of our colleagues in the office, but can we also communicate it adequately to our clients, the decision makers in insurance companies, the trustees of pension schemes. So perfectly reasonable to have a complex method, but can we at the end of the day articulate the results in a way that our clients understand? Things like Joseph was saying, can we explain the rationale behind the age period and cohort components? And the other perhaps observational plea I might make as part of this consultation is whatever methods we look to go with in the future, could we do an element of sensitivity testing at the point of publication? And the sort of things I might include there are what happens if we vary the age range or the time period over which we fit the model, which historically we know has been given variable results in the existing model. What happens if we change some of the constraints? So, for example, in the existing model, we have a series of constraints which do inform the age period cohort decomposition. What happens when we get a couple of years of volatile experience like we've seen recently, and just help us understand where we might go over the next few years, and therefore, when we're presenting advice based upon predictions coming out of the model, they're appropriately framed around the certainty we might have, or perhaps more importantly, the uncertainty that's there, and therefore appropriate decisions are made. Thank you.
Thank you for your comments. Certainly, yeah, the challenge of a statistical model that is informative, but yet one is that we can communicate with, is certainly a topic that we've been discussing at committee. And then your second comment around testing, certainly we'd like to test the stability of this model on. We can work back in time on the England and Wales data set, which we have been doing. We can extend that, and certainly other data sets, other international territories, potentially just to see if there's any other outcomes, any other learnings. So for sure, yes. Thank you. Okay. Well, if there's no more, was there?
I was just going to comment that if we end up with an approach that doesn't have some of the features that the P-spline smoothing has, which we step back an arbitrary 2 years and it's predicting something which is not consistent with itself, I think that will be an advantage.
No more question? Okay, just before I do hand over back to Tim, the committee would like to just express its thanks to Simon Donnelly and Kishore Ananda, who have been supporting the committee on this strand of work, which we gratefully appreciate their efforts. So, thank you.
Right, I'm just going to pick up on some other issues. Not going to go into a lot of detail about these, just run through them very briefly. So first of all, subject of coherent modeling. So coherent modeling means if I've got a number of different populations, do I model them separately and ignore the fact that they might give me contradictory results, or do I try and mix them together and analyze how they vary in a mutual way? So examples of populations you might look at are males versus females. You might look at the UK versus the rest of the Western world. Or you might actually be looking at subpopulations within the UK. So if you're looking at a pension plan where you've got a subset of the national population, which is actually then again weighted towards people with larger pensions, you might be interested in those results. This is really quite a difficult problem. By quite difficult, I mean really difficult. But it is important for longevity modeling, but it's not actually on our initial list of things to do. We'd quite like to dip our toe in the water a little bit, but it's not actually on our list of things to address immediately. Although I think it might surprise an external observer that it's not already in there. I think what we do is essentially look at the results. Do they look reasonable? Yeah, okay, move on. We do, however, plan to test whatever we come up with as a model as far as we can in different locales. So as a way, it's very difficult to find independent data to go away and cross-validate your model because the Western world kind of moves as one. And we already had the topic come up around recent mortality. It's been the same in the rest of Europe or in the US. But nevertheless, it is a way of protecting against a little bit of overfitting. So if I go abroad, a comment we get is we're obsessed with cohorts, which is not surprising when you see the heat map. But then we're a little bit surprised that everybody seems to just ignore the cohorts in their own countries completely. So it is a plan that we test whatever we come up with in different locales, which is interesting because a consequence of that is the CMI could have an implied mortality projection in other countries. So we're trying very hard not to step on the toes of our fellow actuarial professions. And as I mentioned earlier, we are talking very closely to the Society of Actuaries so that they're very abreast of what we're doing. We do expect to retain the requirement for some user input. If you go abroad, again, this is people are surprised when they come to the UK that they can't just pick off a table of mortality improvements. Why can't I have that? So it's a feature of the UK. It's not what happens in the US. There's just one table. It's not what happens in Canada or places like that. But I've checked with the IFOA management board, and they're very clear that this is the way we're going. You're big boys and girls, and you're required to put some judgment into the model. Because when it comes down to it, in the long term, we're all using judgment to inform that. It also helps, actually, in real life, is that if I'm talking to a consultant from a competitor, I can have a conversation about how strong their mortality assumption is compared mine, because we use the long-term rates effectively like you might use implied volatility in the options market. It's a way of getting to an understanding of how strong our mutual pricing is. Cause of death modeling. So the irony is you can't really use the CMI model without having some insight as to how causes of mortality by cause of death has progressed over the past year. So when Joseph's saying scientific understanding of the components that underlying the model, you would expect cause of death to feature as part of that. But the CMI's job is not to produce the answer to everything. There's a limit to how much time and resource we do, and we're leaving cause of death or cause of death modeling to other interested parties. One thing we are thinking that we will do, though, is when the CMI model was first published, there was quite a lot of additional data that came with the model, which gave people a background, a way of saying, I can get my head around what might be a sensible basis to start thinking about long-term improvement rates. And if we have time, we would like to rework some of that, or maybe take a fresh look at that and incorporate that. But that's on a kind of nice-to-have list. So those are other issues. I'd just like to end up on points of transparency and openness. We're working very, very hard to make it possible for you to see inside what we do. So it is a way that we do modeling. If we can do it, you should be able to do it with we should provide you with the data and the tools that we've used so that you can go away and fit the models yourselves. I mean, it's very self-interested. Is that way we end up with a more robust model? It's more useful to you and your subscribers, and everybody wins. So we're very interested in that. So just on that note, a couple of years ago, we revised our approach to fitting base tables. We had a graduation modeling working party. That report is available on the website and will actually be publicly available, not just available to subscribers. The software we use to calibrate base tables, that's available if you're keen to download it. High Age Modeling Working Party, chaired initially by Neil Robdons and then by Steve Bale. That's also available publicly. And Steve also mentioned heat maps. Turns out 1 in 20 European males is colorblind, which means a sizable chunk of the people in this room can't see conventional heat maps. Sounds like a small thing, but we want to make our heat maps actually useful. So instead of having look very pretty rainbow smooth charts, we've used a color scale, but the software to produce that color scale, again, it's on the website if you wanted to use it. So we can all have the same consistent heat maps. So those are issues that we're not actually planning explicitly to cover, but we think are important to be aware of. We're now just going to open the floor just in case you have any other questions, any points that you think we've missed. I'd like to stress that you don't have to wait for a formal consultation meeting or a formal consultation exercise. You can ping us. I think there's an email address on the front of the slides. It's projections@cmilimited.co.uk, or you can contact one of us. We're really keen to hear from you if you have a sudden thought that you think, well, or you're working on something you think the CMI might be interested in that. We're very, very open to your thoughts. So that's our address. So just like to open the floor in case anybody has any other questions that they would like to ask about the direction of travel, or any suggestions or recommendations for things we may have missed or that we should be doing.
Hi, thanks. Kenny McIver. I just wondered, actually, rather naively, if the CMI had considered linking the population data with any other data sets that contain perhaps more predictive variables, like NHS data, for instance, if it was rich enough in order to further this goal of predictive model rather than a descriptive one, perhaps.
So that's a fascinating area of activity. We're drawing a line around the level of sophistication we're going into. I think we could happily spend all our budget just looking at that issue by itself, and we wouldn't have. So at the end of the day, we're not aiming to provide you with the end point and the final answer, because that we never get to that point. So we are saying we will we'll be very precise about our aims. So our aims are to essentially to use a population-like data set to predict, based reasonably well informed in the sense that Joseph outlined, is, you know, or Daniel mentioned, do the graphs actually stack up given what we'd expect given our general knowledge, but to aim just to have some limited goals and then try and deliver on those. So it's very interesting, and I'm sure lots of people are looking at that, and there's a chap at the International Symposium last year, I think, last year, who was talking about this, and it was all very exciting, and it just looked like there's a huge amount of data, but just getting through the data and getting the data to actually be consistent feels like a job in itself. So we have a very, very limited set of goals, which are difficult enough. There's a chap at the back.
I go first.
Oh, yes, sorry. Okay.
Paul Hopkins, I've got two questions. You mentioned all this very important stuff that you haven't done yet and may not do, according to that last slide. It is important for longevity modelling, but we may not address it. Is this purely a budgetary constraint, or is this sort of question of avoiding intellectual indigestion by not running before you walk? And the second...
I wouldn't have used precisely those words, but it is don't run before you can walk. So coherent modeling it feels to me like it's something that seems very obvious and we should do, and all you have to do is plot a map of male versus female mortality on a 2D grid, and you can see there's patently something very significant going on over the, centered on the 1970s, where the rates moved apart and moved together again, and that maybe we would have had a better predictive model if we'd modeled the two together back in the day. But that's something we'd really like to get our teeth into. But maybe the first thing is to either tweak the CMI model or get the Kalman filter thing working in a way that makes sense, go away and test that robustly, then go and have a look at this. So it's the don't run before we can walk.
And the second question was, I don't think you mentioned anywhere the PRA, and given the potential consequences for capital positions of annuity writers, has the PRA expressed any interaction or interest in what you're doing?
I know the PRA somebody from the PRA, I think, was at the SciAS meeting that we had last year. We are very sensitive to the notion that if we come out with a massively different model and we go, hey, look, everything's changed, chuck all the balls up in the air and they landed in different places, then we're very sensitive to the potential harm and difficulty that would cause. So one of the reasons why we've got a 12-month consultation period is so that people can get their heads around that. And I think, and when it comes down to it, there would be some user-defined parameters, and we're probably not looking to massively change things unless we've got some very good justification. But going back to the initial slide, which is, how volatile should the model be? So in the light of the data that we've had over the last, this year in particular, but also the last 4 years, we would like something a little bit more objective, maybe semi-objective at least, to get our hands around that. So we haven't liaised directly with the PRA. I know this has come up in committee, so I'm sure we won't ignore that. There's a chap at the back. Sorry.
Gavin Watts. So one of the things that I really like the form of the CMI model at the moment, I like the currency of being able to talk in long-term rates, working pensions probably for background. One of the things that is slightly confusing perhaps to explain is the what I think has been referred to as extreme trend reversal. And I think if you're looking at a method of putting sort of a predictive element in, perhaps continuing on that short-term sort of trend into that short-term blending would be quite interesting. I don't know if anyone else agrees or if that made sense.
So extreme trend reversal, I mean, I'm probably going to not go into detail on that, but I mean, it was because extreme trend reversal, I think, was posited as a notion that the CMI model was over-predicting future mortality improvements, and actually the reverse has happened. So that doesn't strike me as an immediate headache, but actually there is something around the trade-off between predicting short-term noise. What do we mean by so we've talked about long-term and medium-term, but we don't have clarity on what those mean. And then I can't imagine that a long-term rate is not going to be part of the model in some way, shape, or form. So the long-term rate has some issues. So I think Martin Lowes referred to the fact that the model's predictions, if followed, would result in a different prediction when you recalibrated the model to them. So some issues around that when you use a long-term rate, but it feels like common currency. And for us to remove that from the equation would be quite a big step.
Sorry, I'm talking about definitely keeping the long-term rate. It's more the initial trajectory of the short-term rates blending into the long-term rates.
So if in Steve's session on the Kalman filter, I think so he was using the analogy of a ball, presumably just stopping hitting a brick wall or something. But we would look at factoring in not just mortality improvement, but the rate of mortality improvement. And then there is something about if your mortality improvement is pointing upwards, how does it then come back to your long-term rate? And that's kind of in the to be investigated box. I have a lot of sympathy with the notion that there's momentum to mortality improvement rates, but that's still to be tested. It's still for us to form a view, and it might be that we don't form a view. We have two options, which we consult on. So we don't really know where we're going to land on that. So Martin?
Slope as well as the position, I think would be good.
So you're saying do model the slope? Yes. So it is an interesting feature about the CMI model is that the continuation of current mortality improvements doesn't actually have to match with the slope of current mortality improvements. So, but there is some. So it's difficult enough to mortality improvements themselves are really difficult to model because once you get a bit of volatility, even getting to the mortality improvement rate is really difficult statistically. Modeling the rate of change of mortality improvement is now an order of magnitude harder because it's that more sensitive. But nevertheless, we are thinking very seriously along those lines, and that's one area in which the Kalman filter probably shines because you just add another state variable. I simplify a little bit.
It's not just, if you like, the numbers behind it. It's when you present it to clients who maybe aren't as well informed as what matters and what doesn't matter. If you're showing graphs that don't join up, that can cause difficulties. And
yes. And if I were advocating the Kalman filter, then hopefully the Kalman filter thing would say, here's the underlying signal, and it automatically joins up. But also, we didn't do that 2-year step back thing because we've actually got current rate of improvement or rate of improvement change, and also we've got some uncertainty surrounding that. But that's kind of in the difficult to do box. Any other questions? In which case, Deborah. It might be. I think we managed to scatter the microphones to the corners of the room.
Deborah Cooper, sort of a naughty question after what's just been discussed, but pertinent because we're talking about the complexity of the model. We don't have, and your slide there mentions UK versus the Western world. We don't have Scotland in our data or Northern Ireland. They might be relatively trivial to those of us sitting in London, but quite possibly they're not because Scotland has special problems.
So it was quite interesting going out to Edinburgh and talking about the CMI model, which is not actually calibrated to Scottish mortality data. We are very aware of that, and there's probably some other issues about the fact that no one actually based in Scotland is actually on the CMI Mortality Projections Committee because of some locality issue, which I think I am concerned about in a separate sense. In terms of getting hold of that data, we have that on our list of things to do, and I think we have it on our list of things to do in two senses. A, it does feel odd that we're a UK profession and we excise 2 bits of the UK where the data is a little bit less timely. So there's an issue there. But also, if we wanted to analyze, so back to kind of the coherent modeling in a way, is how do you actually analyze data from a a country, say Northern Ireland, which is smaller population and therefore more volatile, how do you analyze that and make sense of that? So the Dutch did something along these lines where they modeled Western Europe and then they modeled the Dutch population. I mean, they did it using Lee Carter or Lee and Lee, but they modeled the Dutch population relative to the rest of Western Europe. And that's an approach to doing coherent modeling. So we are actually quite interested in, could we do Northern Ireland or Scotland separately, as well as doing the UK as a whole? But that's in the nice to have box after so let's tackle the big issue. But we are very alive to the fact that we have a body of actuaries up in Scotland who are using a model calibrated to England and Wales data, possibly to predict liabilities for people in Scotland, which seems a little bit disconnected to me. But we have that on our list. I think there is something, historically there's something about timeliness of data, where the ONS are actually quite quick in terms of producing stuff, and the weekly death data comes out really quickly.